Hello friends, so today's topic is regular expression to DFA conversion. Now in this video we are going to discuss the longer method of conversion of regular expression into DFA, and this particular process is performed like in this manner. So first regular expression is converted into NFA with the epsilon move, and then NFA with the epsilon move is converted to NFA without epsilon, or you can say simply NFA, and then finally NFA is converted to DFA. Now, as you can see here, there are three different conversions there. Now, these two conversions we have already discussed. These two conversions we have already discussed. For these conversions, for NFA with epsilon move to NFA without epsilon move, you can refer to the video number 10 in this playlist. And for NFA to DFA conversion, you can refer to the video number 9 in this playlist. Now, only we in this lecture or in this video, we will discuss only this transition or this conversion we will discuss, and then remaining conversion you can perform yourself. So to perform this conversion, we will use one regular expression as example. So I will take it as 0 plus 1 whole positive closure of 0 plus 1 and 0 0, positive closure of 0 plus 1 and 0 0. Now you can see, my friend, this is the regular expression, and for converting this into NFA with the epsilon move, what we can do, we can break this regular expression into different pieces. So and let's see how it is broken into pieces. So you can see first part we can take this positive closure. So I can take 0 plus 1 positive closure, and then second part we can take as 0, and third again we can take as 0. So you can see, my friend, all these parts are connected with each other with the help of dot, or you can say concatenation operation, so I have created three different pieces of from this regular expression. Now what we can do, we can create NFA or DFA for all these pieces individually, and then we can combine all these DFAs or NFAs with the help of epsilon transition. So it will become NFA with an epsilon move. So now we can see how we can do it. So this particular positive closure will have at least one symbol, either 0 or 1. So we can create for the a machine for this, like suppose Q0 is the initial state for this, and it is initial state, and then single 0 or single 1 we can have to reach Q1, and then to accept any number of zeros and 1 we can go back to initial state using epsilon transition, and then you can say, my friend, if we consider this as final state, then this machine will accept either single 0 or single 1 at least, or it can accept any number of zeros and ones. So this will, the language of this DFA, or sorry, the language of this NFA would be the positive closure of 0 plus 1. So for first part, we have created the machine. So this is first part, this is second part, and this is third part. Now our second part is 0, single 0. So what we can do to accept single 0, we can create one more machine there where Q2 is the initial state, and we have only one transition of 0, and then we will reach to Q3, and this Q3 would be the final state for this particular part. Now one more machine we can create for third part, which is again 0. So again we can have the same kind of machine there Q4 as initial state, and this would be the initial state for third part, and single transition of 0 would be there, and we will move to Q5, which would be the final state. So for all these three parts, we have created the machine. Now we can combine all these machines with the help of epsilon transition, and this the resultant machine would be the NFA with the epsilon move. Now you can see, my friend, how we can connect them with the help of epsilon transition, so that our NFA with the epsilon move will have only single initial state and only single final state. So these three different machines are having separate initial states and final states. Now we will connect all these machines with the help of epsilon transition. So now how to connect it? Let's see. So now see, my friend, first part is concatenated with the second part, and then these two are concatenated with 3. So that means all these three machines will be connected in a series. All these machines will be connected in a series. So first part is this, second part is this, third part is this. So now for first part, whatever the first initial state of first part is, it will be the initial state of final machine or final NFA with the epsilon move. So I can create one initial state as Q0, which is the initial state of complete NFA, and then I can have one transition of 0 or 1 there to Q1. Now, this would not be the final state, because it is only accepting the first part of regular expression. So, this must not be the final state. So, it will have all the transition of this machine, but the only this state final state would be will not be there in this machine. Now I will connect it with the second part of this machine, which is where as this. So I will use one epsilon transition, then I can connect the initial state of this machine with the final state of this machine. So final state of this machine was Q1. So I can connect it with the initial state of next part. So this would be Q2, and then single transition of 0 there, which will reach to Q3, and again you can see, my friend, Q3 will not be the final state, because we have to connect one more part of this regular expression. So now third final state of second part will be connected to initial state of third part. So now with the help of epsilon transition, so I can create one epsilon transition here, and I can create one more state here as Q4. Then for single 0, we can create one transition here, so it will reach to Q5, and this is the third part and the last part of this machine. So we can create the final state of third part as final state in the resultant machine. Now you can see, my friend, all these machines are connected in a series. So now the language of this particular NFA where the epsilon move would be the language of this regular expression. So this is how you can create uh, NFA where the epsilon move equivalent to any given regular expression. Now I will take one more example here, which will show you the different type of regular expression. So it is A asterisk B or plus B asterisk A. B asterisk A asterisk B plus B asterisk A. So this is your regular expression, and all valid strings of this regular expression will be coming from either this part or this part. So now we have two choices here. We have two choices here, and we can simply break this first regular expression into two different parts. So first part would be this, second part would be this. Now this first part can further be divided into a asterisk dot b. So we can call it 1 1 and we can call it 1 2. Then this again can be further divided in as b asterisk dot a. So now this we are calling as 2 1 and this we are calling as 2 2. Now you can see, my friend, these four parts of this regular expressions are there, and these are two first two part are connected with dot, second two part are connected with dot, and these two part are connected with plus. So that means we have choice. These two are compulsory thing, these two are compulsory thing, but these two are choice. So how we can implement this, or we can create regular in NFA with epsilon move for this? Let's see. So now we can create machine for this. First we can create machine for this. So we can have single state q0, which will also be the final state. So this would be a, and then this is machine for a asterisk. Then for this we will have q1 as initial state, q1 as initial state, and single transition of b would be there, and it will reach to q2. So this would be the final state for second part 1 2. Now another machine we will create for part 2 1. So that would be same as like this. So again we are taking one more state here, q3, which would be the initial state and the final state both. So and this will have the transition of self loop of b, the self loop of b. Now for this particular part we can create a machine again. So we can create a machine for this part 2 2. This is for 1 1, this is for 1 2, this is for 2 1, and for 2 2 part we can again create one machine like this. So I can have one initial state as q4, and I can create one transition for A, which will reach to Q5, and that would be the final state for this machine. So we have created the machines for different parts, different parts. Now remember, my friend, we have to connect first two machine in a series, last two machine in a series, then both series we will connect in parallel. So now you can see, my friend, how it is done. So first two machines we have to connect in series. So first initial state of this part would be q0, q0. Now it would not be final state because it is not the machine for complete regular expression. So this would not be the final state. Now one more epsilon transition we will have, then we can use one more state q1, and which will have one transition of p there, and this would be the final state of final state. Now again we will not create the final state here. Again for last two part 2 1 and 2 2 we will connect as a series. So again we can create one. See, for this particular part we are going to create, for this particular part we are going to create one series. For this particular part we are going to connect this series. Now, you can see here, for these two parts we will connect as a series. So again I can take Q3 as initial state, and I will have one self loop of B here, and then I will connect this machine with this with the help of epsilon transition, and it will have Q4, and from this Q4 we will have one transition of A, which will move to Q5 finally, and this would be the final state for this. Now, my friend, for both the series we have created NFA. For both the series we have created NFA. Now we have choice of either this part or this part, and we have machine for this part and this part. Now we need to connect these two machines with, so that our final machine would have only single initial state and single final state. So how to connect these two machines in parallel? So see, connect both the initial states of machine with another state and make it at initial state. Make it as initial state as Q6. Now these two states would be connected with the help of epsilon transition, so that it is now having only one initial state, and it is Q6, my friend. It is Q6. Now we need to have only one final state in the machine. So I will not make, I will remove these final states from this machine, and then I, I will create one more state there. I will create one more state there as Q7, and I will make this as final state. And these two final states would be connected with the new final state with the help of epsilon transition. So this is now the machine for this complete regular expression. You can see, my friend, what we have done. We have first divided the whole regular expression into different pieces. So in this particular expression, we had two choices. So for first choice, we number as 1. For second choice, we number as 2. Then we divided first part into two different parts as 1 1 and 1 2, and second part as 2 1 and 2 2. Then we created machine for all these four parts. Now the machines for part 1 1 and 1 2 are connected in series, so that we connected in series. And similarly, for machine for part 2 1 and 2 2 are connected in a series. Then that also we have done. Now as we have choice of either this part or this part, so we need to connect them both these part in parallel. So what we did, we created one single state, initial state, and we connected it with the help of epsilon transition. We connected it with the both the initial state of machine, and now this has only single initial state. And similarly, for final state, for creating single final state, what we did, we had we created one final state there, and we connected both the final state with the help of epsilon transition to that state. So now this is the final NFA with the epsilon move for this regular expression. So I have taken two different kind of regular expression as example. So I hope, friends, it would be very much clear to all of you. And still, if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.